It is started. I neglected to have our group discussion pulled up. Has everybody else got it pulled up?
Yes.
Okay.
Yeah. Because actually, I thought we were supposed to go through the 2 questions before we went through the quiz. The last 2 questions on the.
Right.
Mm-hmm. Okay. Oops, wrong thing. Okay, so the last 2 questions on the preparation sheet.
Yep. So it should be questions 5 and 6.
An 8-sided die has 8 possible outcomes for each roll. Calculate the probability of rolling a number greater than 5.
Three, 7.5%, because it said didn't say equal 7 and 8, which is 3 out of 8, which equals the 37.5%.
Yeah. So the possibilities over the number of possibilities.
Yeah.
There's 3 over 8. That's right.
Okay.
Right.
So I guess it's not a number equal or greater to, it's a number greater than 5.
Yeah.
Okay.
And then question number 6 was calculate the probability of not getting a number greater than 5. So to me, that would include 5. The remainder, which is 5 over 8, which is 62.5%.
Yeah, 5 over 8. So 8 possibilities with 5.
Right.
In the numerator, yeah.
I like it when lessons like this make sense.
Yeah.
Or I can see application in other areas, I guess is what I'm getting at in regards to that. Okay. Group meeting.
Okay, so I'm just now pulling up the quiz.
Me too.
Yay. It's only 13 questions in this one.
I think question 2 should be like at the end.
Yeah.
In my
at the first.
Yeah.
Yep.
Give all your probability answers as decimals. Okay. Okay, so the information for question, use the following information to answer the next 3 problems. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and the proportions given in table above define a probability distribution.
Yeah, so you go through the 2 rules. And one rule is they've all got to add up to 1, right?
Right.
And what's the second rule?
Hold on. Let me go find
Like, I have it written down here.
Exactly.
That's it. We're going to go find it.
I do not have that memorized yet.
Okay.
Probabilities of all possible outcomes must equal 1, which is the one that you just said. The probability of any event must be greater than or equal to 0 and less than or equal to 1.
Yeah, so that's between 0 and 1.
Right.
So all of them do, don't they? And they all add up to 1. So it looks like it is.
85. Yep, that would be right. True. And then question 4, what is the probability that a randomly selected person in the United States has type 0 blood?
So in this one, I think it's like the problem we just did, right?
Yeah.
You've got to use something in a denominator, which is what, 4? 4 possibilities?
Right, there's 4 possibilities.
Question is, what do we use in the numerator?
I'd say, what, I don't know.
I'm
Is it
looking at
just
my
one?
lesson. I'm going back to my lesson.
There seems to be 2 choices here.
Well, because we would have to put that, because O type blood, that's in a decimal, so we would have to convert that over into a fraction to get our numerator.
Yeah, there's 2 choices to set up the problem in the numerator. One is you say there are 4 choices, and this is one of the 4. Or because they gave us a proportion, you use the proportion.
What is the probability?
So with the die, we use the number, right?
Mhm.
It was much easier with the dies.
Right? That makes more sense to me.
So which one do we use?
Well, because doesn't it say type O blood?
Right.
Right.
Probability that a randomly selected person in the United States has type O. So wouldn't we take,
So the proportion says that there's 0.45.
so we would
45%.
have to convert that to a fraction, right?
Yeah, divide it by 4, right? I guess. But does that comes up to be 0.11?
11.25%.
Now, is that correct? Because we're talking about probability here.
I wish I could fast forward through the video that we watched because it covered things like this. Oh, I guess the Columbus issue. Maybe not.
Do you remember the particular problem that the guy did on the video? We have the number of girls in 3, the colored M&Ms.
Did I watch a different video? I don't remember colored M&Ms.
This was the summary one as he went through the problems.
Oh, yeah. Nope, I didn't watch. I barely made it through the reading. I didn't watch the summary of the reading. I watched, what was it?
The other one was the one, the slides that they had. That was the M&Ms.
I did not watch the lesson 4 video tutorial, but I watched the lesson 4.3 probability rules, mean and variance of discrete random variable.
Right, that's the PowerPoint presentation.
Yeah.
Oh, my-
That a randomly selected person in the United States has type. Okay, do we have to, wouldn't the probability be 0.45? Wouldn't that just be the answer?
45% should be, right?
But it says round to 2 decimal places. So shouldn't it be 0.45?
You know,
Why am I making this harder than it actually is?
because I opened my mouth, that's why.
And he shows
Yeah,
the
no, I
value
think
of 1, 2, 3, 4. Probability count being px is a quarter or 25%. And so he was going through saying that was the count of 25%. But then he went through and he did the value times the probability, which he did 1 times 0.25 and 2 times 0.25 and went through that.
Yeah, but in this case, it's already been broken down into You
Yeah,
know,
I
if we were randomly selecting amongst the population, only 45% of the population
Right.
has type O blood. So wouldn't that be the answer?
percent. I think you're right.
Okay.
Mhm.
Wow, I was making it harder. Was anyone else making it harder?
I was trying
Yeah,
to.
I was totally making it harder. Yep.
Yeah.
And so what is the probability that a randomly selected person will not have type O blood? It would be everything else. It'd be 55%, 0.4,
Right.
0.55.
Right.
High five.
Okay. Wow.
Wait.
If we get it wrong, it's my fault.
Yeah. And we all agreed.
Well, though we have 2 tries on this one, so it's all good.
Yeah.
So we'll have to do some serious research to be able to. Wow. Okay. So who wants to read the next section?
I can
Right.
do that.
Go ahead.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question number 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
So it's 1 out of 7. Right?
Yeah, because there were 7 bowls.
Yeah. So
One of them.
So I'd say 1 out of 7.
Right, because it doesn't even give us a number of dogs that are participating, so we wouldn't even need to look at that.
Right.
Are we needing to answer this one in decimal point as well?
It says
I think so,
around
because it says round.
decimal places.
Yeah.
Oh, hello. So sorry.
That would be 0.143.
yeah, that's what I got.
That's what I got.
Okay.
Okay. In the combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random choice alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect cancer bladder, or there is little evidence that dogs can detect bladder cancer, sorry. So it looks
Out of,
pretty good chance.
I was going to say out of 54 trials, that's less than 50% of a chance.
Yeah, it's 0.407.
Chance is 14%. 50% is much higher than 14%.
Right.
So it would just be random if you just picked anyone. So I would say that it is a strong evidence. Out of the chances of just randomly picking and laying down. Any thoughts?
Sorry, I wasn't saying seriously about baby crying in the background.
Sorry
I
about
was
that.
trying to do some math. And I mistyped. I'm like, seriously? And no worries about baby. Been there, done that.
Yeah.
Mhm.
Okay, so Grant, didn't you say that it was 14% of a chance?
Yeah, so we said 1 out of 7,
Uh-huh.
14% if it was just random. 7 samples, just pick one and lay down.
Right.
You 14% chance of getting one right sooner or later, right?
Right.
So if the dogs identified 22 times out of 54 trials,
Right.
that's close to 50%, a little less than
It's
50%.
about 41%. That's the math I was doing.
And that's pretty significantly better than just the 14%. If we had been 15, 25% maybe. Maybe it wouldn't be good, but you're well to double that.
Yeah, I can see that.
I think the real question is how much more do you expect that the dogs are going to hit it?
Right, and I think it's kind of objective as to how to answer that question.
Very
So
well could be.
if I want to use dogs to check for cancer, I'd like it to be more in like the 80% range that they can actually
Yeah.
out, if you will.
But in this case, if they could narrow it down to half the people, now we know, we got a better chance of finding them than 0, right?
Right.
If we were 80, that would be better yet. But
Well, I guess, yeah, 41% is definitely greater than the potential probability of 14%.
I was just thinking.
I guess we can always say that this does provide strong evidence and hope for the best.
Well, if you say you double just chance, so that's going to be 28%.
Right.
And if you triple it, that takes you up to 30, 40, 42%.
Right.
You quadruple it, and now you're getting, even better, but you got a 3 times chance better
Right.
than what would just be random.
Good puppies.
Yeah.
I don't know.
Yeah, nope, I'm
Also,
good with that. So who wants to read the next section?
I can do that.
Okay.
So it says M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following following table. Brown 0.13, yellow 0.14, red 0.13, blue 0.24, orange 0.20. If you reach into a black bag of plain M&Ms, what is the probability of drawing a red-colored candy?
The 0.13, right?
Yep.
If we're doing it like the first problem.
Yeah.
Yep.
A red candy is 0.13.
Yep.
I kind of disagree with their their table here.
You think there's more browns? No.
I do. I feel like there's tons of browns.
Yeah, I don't feel like there's as many blues.
No.
That green.
Yeah, why'd they cross out green?
When I
Oh,
was-
I guess probably
That's the next question.
exactly.
Question number 9.
I was just looking at
What's
that.
the probability that a randomly selected candy is green?
That would be why it was.
1, right? So we have to add it up.
I got 0.16
That's 0.13.
correctly, but hang on, let me do it again.
0.16.
Yeah, I got 0.16.
Me too.
Yep.
What is the probability
Okay.
that a randomly collected candy is not green?
0.84.
Right?
0.84. Yep.
0.4, right?
Did you say 0.4 or 0.84?
0.84.
Yep, that's
Okay.
what I thought as well. I just wanted to make sure.
Good.
Okay. ACT. Woohoo! Hey, I was above the mean. 20
Good job.
ago.
I honestly don't even remember what my score was. Let's see. Okay, so the ACT scores, oh my gosh, of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. And half of the observations are less than or equal to what number?
24.3. Isn't that right? Or is it 24?
That would be the mean.
Right. That's what I thought. I
So
just wanted to make
24.3. Yep.
Okay.
the information on the table above the top 25%. Top 25, so that would be the Q3. Isn't that right? That would
Yeah,
be
75%. Now, that represents 75% and everything down below it. The top 25 is going up toward the max.
right, and that's why I'm saying that it would be the Q3.
Yeah, it'd be higher than 27, right?
Right, so it would be from 75 to 100.
To the max, yes.
Right.
And how did they word this?
Based on the information on the table above, the top 25% of the students scored above what number?
27.
Yep, that's what I have.
63. Yep. Ooh, last question. Which of the following statements is not one of the 3 rules of probability?
Well, we started with this.
Right.
Right?
Probability is a number between 0 and 1. We know that one. If the probability is high, then the probability is positive. I would say that number 3 is wrong. If the probability
Yes.
is high, then the probability is positive because it was saying it can never be negative.
Yeah.
Right.
Yeah, because it has to be at least 1, add up to 1, has to be between 0 and 1, and then it talks about the 1 minus the probability. It will occur, yes.
All right, saving all my responses and fingers are crossed.
Now we missed one.
I wish the score was at the top.
We missed 11.
So half of the observations are less than or equal to what number? Then would it be median at 24 rather than mean?
Yeah, probably.
Okay. Do we feel like we
Okay.
need to take it again? Can we take it again?
You can,
We
you can take
Can
it.
take it again. But even then, we got it's percent.
Oh yeah, no, I agree with that.
You can take it again
I'm
if
like,
you want.
Well,
I think we can still take it again, though.
All right.
if we take it again, do we have to do that together or?
No, I think we could do it separately.
Okay.
Yeah.
I think that's all good.
All right.
Oh, wait, hang on.
Not all that we have to
Yeah,
cover.
it says attempts allowed 2. So there are 2 attempts allowed.
Okay.
So, yep,
At least we didn't fail it. So sweet.
right? See? So that was good. We were totally trying to make it harder than it was.
And I definitely think that I need to review mean and median again. I'll just do that on my own.
Nope, it's all good.
Did you guys notice that on the homework assignment, it says you are encouraged to collaborate with other students on the assignment?
Yeah.
Do you guys ever do that?
I thought it also said you're not supposed to post them and discuss them online. So I don't know.
Well, I think you're supposed to like do this.
Yeah.
Yeah, we could do the Google Hangouts, but not post it like on the discussion board.
Right.
I see. Yeah.
Yeah.
So I guess if anyone feels like they need to collaborate, we know each other and can communicate with each other if we feel a need.
And on the Hangout, if you look on your Gmail, right, you can see if someone's on.
Right.
Yep. Like I called everyone earlier and I was like, oh crap, I didn't mean to.
Yeah, I saw that
Sorry.
come through. But it hung up
I'm
pretty
like,
quickly.
I did. I was like, oh shoot, hang up. Don't call him yet. It's only 7.
Oh, that was.
Sorry about that. I was just testing.
So when I post this link, since Landon didn't participate, I don't include his name. Is that correct?
Yeah.
I believe so.
Yeah.
Okay. And
It
we
should
have
be
no
everybody
idea.
that
He
participated.
may have even dropped the class, but I guess we'll see. We'll see if
I don't know.
next one. Does anyone else want practice starting a Google Hangout so that they're prepared?
I can
You
do
know.
it next time if you want me to. I know how to do it.
Okay.
So.
Misha, I know that you wanted some prompting through. Do you?
Yes, I would feel better if I had somebody walk me through it the first time, because I'm like, I have the Go Live thing, I have the Google Hangouts thing. So do you go straight from the Google Hangouts
Mm-hmm.
and then call everybody from there?
No, I Google from YouTube, from the Creator
Okay.
Studio in YouTube.
Okay. So I think I've got it then. Because I wasn't sure which one to go through.
Mm-hmm.
So I've got both of them. So I figured it was probably the YouTube one, but I wasn't quite sure. So
Yeah, I think.
I can do it next Monday
Okay.
then,
All right. And if
if Alan wants to take Wednesday.
Yeah, I can do Wednesday.
if you have any problems,
Okay.
you know, you've got my cell phone number. So
Yes, I do.
I'll do that.
Okay,
All right.
sounds good.
Anything else that we need to cover?
I think we're good.
Okay.
I'm good anyway.
And if I ever seem too loud, will you just let me know? Tone it down just a little bit. I'm reminded in primary of my, I need to hear you and please be quiet. Maybe you guys need like a quiet sign. Quiet down just a little bit.
No,
Nope, just fine.
you're good.
Sounds good. Then we'll call it an evening and we'll talk with you guys on Wednesday.
All right. See you later.
Sounds good. Thank you.
Thank you.
Have a good night.
Good night.
Bye.